Well, in my primary job, I've been trying to win the America's Cup over the last 7 or 8 years. And, you know, to win the America's Cup, you have to really engineer a very fast sailboat, and you have to sometimes, you know, think out of the box and come up with a radical new design. And we did that. The tribrand you see on the screen, which will be representing us in the next America's Cup, I hope, we'll go over 30 miles an hour in less than 10 miles an hour of wind. So it's actually a hydro. It's got underneath each of the 3 hulls are hydrofoils. So the entire boat lifts out of the water, and it just, you know, sails along. It's more like flying a plane or a glider actually than sailing a sailboat. So I mean, it's radical new engineering. It's extreme engineering, and it delivers extreme performance. And while I was at my job driving the boat, it occurred to me that my other job, we might apply some radical new thinking to delivering high performance as well. I've got, like a lot of families, I've got 2 careers. I've got 2 different careers, 2 different, holding down 2 different jobs. So, next slide, please. And we really need much more performance out of our databases than we currently get. And the reason being is information is proliferating at an astonishingly high rate. Large databases now have reached about 200 terabytes. And those large databases, those extreme databases, if you will, are tripling in size every 2 years. Next slide, please. And that creates a fundamental problem. The disk storage systems that are available today simply cannot cope with the amount of data that has to be moved off those disk drives and into the database server. There's a huge data bandwidth problem. The disk storage system that can store 10, 100 terabytes of data, but they can't move that data off the disks and into the database servers very fast. And we call that the data bandwidth problem. And as these databases get larger and larger, that bandwidth problem gets more and more severe. Next slide, please. By the way, you don't have to have a 200 terabyte database to start experiencing the slowdowns you get because your data warehouse is getting larger. If you look at these curves, you can see that around 1 terabyte is the elbow of the curve. That your database starts slowing down very, very significantly, about 1 terabyte. And even the fastest disk storage systems completely fall apart at about 10 terabytes. Where to scan a table could take 30 minutes. We'll scan 1 terabyte table, 30 minutes. And that's where you get the biggest, fanciest, most expensive disk array. Most of us really have mid-range arrays, or typical network attached storage. So at about 1 terabyte is when the problem, raises its ugly head, and it's just getting worse and worse and worse every year. Next slide, please. Theoretically, there are only 2 ways we can solve the data bandwidth problem. One is we can get clever and figure out how to reduce the amount of data moving from the storage system into the database servers. To reduce the amount of data, reduce the stress on those pipes. And second, which is kind of obvious, is we can have wider, faster pipes and more of them. I mean, in theory, those are the only 2 things we can do to attack this problem. Next slide, please. Okay, so in trying to solve this problem, we had to go beyond just software. So I'm here today to announce Oracle's first ever hardware product. And so that's right, Oracle's going in the hardware business, but we're not going alone. Thank you, Mark Hurd and Ann Livermore and the team over at HP who's worked with us to build the exadata programmable storage server. And the exadata storage server, again, is a combination of hardware and software. And it's intelligent. It's not just a bunch of dumb disk drives. As you can see, there are a dozen disk drives in the exadata storage server. But in addition to those disk drives, there are 2 Intel processors, each with 4 cores of processing capability that allows us to put intelligence right next to every disk drive in the storage system. In fact, the storage system itself runs the Oracle database's fast parallel query software. So we've actually taken capability from the database you normally find in the database server and moved it into the storage server right next to each and every disk drive. Next slide, please. That intelligence built into the storage server allows us to reduce the amount of data that flows across that interconnect between the storage servers and the database servers. Because what the exadata storage server does, it doesn't pass disk blocks back to the database server. It passes query results. It actually runs queries. Next slide, please. So, with the traditional storage array, what happens when you ask a question, what were yesterday's sales? Well, yesterday was September 23rd. And let's assume that our sales table does not have an index on date. If that's the case, what happens is when you ask that question, what are the sum of sales where date equals September 23rd? Literally, the storage array has to transfer every disk block that contains sales data information back to the database server. All those disk blocks have to flow off the storage array and into the database server. And the database server, or the database servers, the grid of database servers, then search those disk blocks and look for the amounts and add them up, where the date is September 23rd. But all the data has to flow across every disk block. Next slide, please. This is in stark contrast, and by the way, you'll see that I'm showing there not a single exadata storage server, but actually a number of them. Again, we have processing capability for each and every disk drive. So what happens when we have the smart storage server? When you ask the same exact question, we actually pass the query from the database server into the storage servers. Then, if we properly striped, and by the way, an ASM, our automated storage manager, will stripe the sales data across all those different disk drives. So that query goes to each of those Intel processors, each of those cores are then active, and we're searching all of those disk drives in parallel. So it's very fast. We search all those drives in parallel. And we're looking for sales records from September 23rd, and when we find one, we pass just the amount field back into the database grid, which then adds them up and gives you a sum. So we have very, very fast query processing, parallel query processing in the storage grid, and we've unloaded, we've taken a tremendous burden off of the interconnect between the storage grid and the database grid by returning query results, selected query results, rather than all the disk blocks. Huge difference. Next slide, please. While we're at it, why don't we also attack the other problem? Wider pipes and more of them. And again, in conjunction with HP, we now have, with every exadata storage server, we have 2 InfiniBand pipes that connect that storage server to the database grid. So we have 2 InfiniBand pipes. And the InfiniBand pipes are very, very fast. Actually, each InfiniBand pipe, if I'm not mistaken, is 20 gigabits. So we actually have 40 gigabits. But just to be completely forthcoming here, the InfiniBand pipes are actually faster than the disk drives that are inside of the storage server. We're only able to move off each storage server 1 gigabyte per second. But with InfiniBand, in theory, we could move 5 gigabytes per second. So I could have used the number 5 there if I wanted to. It would have been telling you the truth. But in fact, the limiting factor is not the InfiniBand interconnect. The limiting factor is the speed of those 12 disk drives, the ability to get data off those 12 disk drives. But that's still an astonishing number. 1 gigabyte per second per Exadata storage server, and you can have dozens or hundreds of Exadata storage servers all working in parallel. Next slide, please. The Exadata storage server grid works with any Oracle database server. Now today, we're announcing that we have, by the way, available for immediate delivery is the Exadata storage server for Linux database, the Oracle Linux database servers. We have that immediately available. But other operating systems and chip architectures are on the way. So we'll be, those are coming, and our intent is to do and support every Oracle database. Next slide, please. Oracle has long had, as an important differentiator, things like security, reliability, and performance. Extreme performance. And the way we get extreme performance is a fundamental belief in what's sometimes called scale out. Don't buy bigger and bigger and bigger machines, because eventually you bought the biggest machine and there's no place to go. We believe in buying more and more and more small machines and using them in parallel, in a grid. And this is just a continuation of that architecture, now applied to storage. So we have an Oracle Exadata storage grid, I should say HP Oracle Exadata storage grid, an Oracle database grid, and a Fusion middleware grid. As you need middleware capacity, add another server to the middleware grid. As you need database capacity, add one to the database grid. As you need more storage capacity, and by the way, it's not just disks you're adding, it's processing and cache and bandwidth, add another storage server. Next slide, please. Oh, as long as we're in the hardware business and we've announced our first product, it's kind of silly to be in the hardware business and have only one product. So I'd like to now announce our second product, the Oracle Database Machine, the HP Oracle Database Machine. Again, I'd like to extend my thanks to the team over at HP and the Oracle Exadata team, for working again over 3 years on developing the world's fastest database machine. Next slide, please. So if you don't want to configure your own grid and your own interconnect and your own storage server hardware and software, we've got it all in a package for you. And up here we have our database servers. Over here we've got our storage servers. And this thing has incredible capacity. We have 64 Intel cores for database processing and another 112 Intel cores for storage server processing. That's a lot of compute power in one box. By the way, there is almost 400 gigs, I think 368 gigabytes of memory in this thing for caching your data in memory. It holds 168 terabytes of disk data. And importantly, for those of you, and I know the burning question for everybody, it holds really a lot of songs. So if you're looking, we're not talking the iPod Nano here. This is 1,400 times larger than Apple's largest iPod. be a while. Even your peer-to-peer network will have a hard time telling this thing out. Next slide, please. I said the exadata project is 3 years old, but of course we've been working on parallel query processing for decades, and we're not done yet. We get a little smarter about it every year. It's a hard problem. It really is a difficult problem. And we're getting better at it, and this is an important milestone for us. We actually started turning these systems over to customers about a year ago. And you can see a lot of interesting names down there, Amazon, Yahoo, and we got some big phone companies with large databases. And they've been testing this system again for almost a year. Next slide, please. And they've been getting sensational results. In fact, you'll hear them in their own words when I'm through talking here. So, a phone company in Eastern Europe found that they got anything from a 10 to 72 times speed up. The worst speed up they got was 10 times faster, moving to the exadata system. Let's look at the configuration. Next slide, please. And they had a pretty big system. They had 2 IBM P-series machines. They had a good-sized, fully loaded EMC storage array. And, oh, by the way, when these customers were testing the machine, we owned the machine, we loaned it to them. So we loaned them half a machine rather than a whole machine because we're really cheap. So the results that you see, and I'll show you the results for Intel in a second, the results that you see are not one of these, but half of these. So half a configuration of a database machine outperformed that configuration of 2 IBM P-series and the big EMC storage array by 28 times. Next slide. Where table space creation was 10 times faster, and then you look at their customer discount report, was over 70 times faster. These are astonishing results due to the fact that we've got that intelligent software, that parallel query software running in the storage array, and the very fast bandwidth between the storage servers and the database servers. Next slide. Let's see, LGR is a company that outsources data warehouses for phone companies, and their experience was queries that ran over 30 minutes now take less than 1 minute. Again, over 31. Next slide. And they had a huge system, a big mainframe computer, huge disk array. Again, half a database machine was 30 times faster than the hardware that they currently have their application. They're looking forward to using the HP Oracle database machine. Next slide, please. A large company, actually the world's largest futures exchange, CME Group, got 10 to 15 times improvement. Next slide, and I go through these things quickly. You get bored. Next slide. Okay. A large grocery chain, Giant Eagle, had 13 IBM CPUs in their pre-series series. They were dual core, big EMC, a disk array, and against half a database machine, 16 times performance improvement. This is against their real workload. This is their actual data warehouse, their production data warehouse. These are the performance improvements we got through parallel, intelligent storage server and much broader data bandwidth. Next slide. And here were their speed ups, where again the best improvement, almost 50 times on one of their queries. Next slide. Then we decided to do something interesting. We took Oracle's internal data warehouse configuration. We just took our configuration, and we use NetApps, and we use an Intel, and we use Linux Grid of database servers, and we just replaced. We mirrored that. We had the same exact number of CPUs running the database, and the same exact number of disk drives running the storage. So it was an exact duplicate of what we had on our current data warehouse. And then we ran the TPCH query set on that configuration. And surprise, surprise, this number comes up over and over again. 30 times speed up. Next slide. And these are the TPCH queries. We've got a paper on this describing it. But it's simply because we have intelligent storage servers and more data bandwidth. Intelligent storage servers running parallel query and more data bandwidth. Conventional disk arrays really cannot compete with that kind of configuration. Next slide, please. The problem with a conventional disk array, and this is all of them, is they move disk blocks from off the disk and into the database server. That's they put a tremendous load on the interconnect between the disk array and the database servers. And these arrays typically have very low bandwidth. They don't have fast interconnects. And with exadata, this big disk array you're looking at has the same data bandwidth as three of these 2U boxes up here. Next slide. The reason, you'll see the red line on below, as you add storage, as databases get larger, our performance stays the same. How can that be? Because with a conventional disk array, as you add storage, you're not adding data bandwidth. As you add another disk drive, you're not adding processing capability. All you're adding is storage. With the Exadata, HP Oracle Exadata Smart Storage Server, every time you add another storage server, you're adding not just disk capacity, but you're adding 2 InfiniBand pipes, 2 processors, and more cache. So the system remains in balance. Next slide. Okay, so conventional disk arrays can't compete with the Oracle database machine and Exadata storage servers. What about database machines? What about Teradata? Well, it's really interesting if you look at the Teradata architecture, that Teradata uses, built into Teradata, is a conventional disk array, a normal SAN. Teradata has no intelligence in their storage server whatsoever. None. They have a pretty sophisticated database. Granted, that's been around a long time, very sophisticated database. And they have a bunch of processors, database processors, if you will, a grid of database processors. But they have that terrible problem that they move disk blocks off the disk array into the grid of database servers. There's no intelligence whatsoever in the Teradata storage system. So they have a terrible data bandwidth problem. They move disk blocks, and their interconnect is very slow. It's an extremely slow interconnect between the storage servers and the database servers. Again, the storage servers just move disk blocks, no intelligence. So architecturally, it just can't compete. It's going to fall apart again on that interconnect, on inadequate data bandwidth. Next slide. Well, what about a newer database architecture, a new database machine, Netezza? Well, Netezza does a lot better, actually, in terms of data bandwidth. Netezza, if you look at it closely, really is a storage server. They got 1 processor per disk drive. And they've got a lot of data bandwidth. They do table scans very, very fast. Not as fast as we do. You know, we have more data bandwidth than they do, but now it's down to a 2-to-1 advantage, or not even a 2-to-1 advantage. And we load about twice as fast. We have a much faster network. 2 big differences between us and Netezza. Our database machine runs Oracle. Their database machine does not. We lose a disk drive right here. Our database machine keeps running. They lose a disk drive, and the queries and transactions stop. 2 big differences. Next slide, please. And our database has been around a very long time. Netezza is missing a lot of basic database capability. B-tree indexing was very big in the late 50s. B-tree indexing's been around a long, long time. I mean, even I studied about it in school. You know, that was a long time ago. So Netezza does very fast table scans. Very fast table scans because of all the processing capability they have right next to the disk drive. But their overall database capability is really primitive. Next slide. This is really an interesting slide, and it really shows the difference in the different database machines. Notice that in database cores, first of all, that we have a lot more storage, 168 terabytes versus 43 for the other machines. But we have a lot more database processing than Teradata. We have twice the database processing as Teradata, 64 cores versus 32 cores. But notice Netezza only has 4 cores at the database level. If you go down, what you see is what Netezza really is a fast storage server. They got a lot of cores. They're focused on that one processor per disk drive. Well, guess what? We have 112 storage cores. Netezza's 1.8. Teradata has none. Teradata doesn't have intelligent storage server. Netezza does. Teradata has a pretty good database. Netezza doesn't. We're the only one that has a balance between storage processing capability in our storage servers, and database functionality in our database servers. We have a balanced system and lots more data bandwidth than either one of them. Next slide, please. You can see if you're looking at our hardware prices, we're at $4,000 per terabyte. We're closer to the price of a disk array than a database machine. The hardware is a lot cheaper than the database machines. Around the same price as disk arrays. Once you buy our software licenses for the exadata storage server, and if you pay list, I know a lot of you come in here and you just say, well, whatever the list price is, that's what my deal with my Oracle salesman. I pay list, and well, I know it's very familiar. The Oracle sales guys never get discounts. And even if you play list for your storage server software, it's still cheaper in terms of capacity and much faster and much more reliable, and it runs all of your Oracle applications today. Next slide. By the way, we're not going to talk about it other than this one slide. This is the only database machine that's designed to run OLTP as well as data warehousing. We don't have benchmarks for you today, but we will next time around. But this will speed up OLTP as well as data warehousing. A lot of people don't realize that 90% of the load in an OLTP system is actually queries and reports, things like that. Next slide. It's available today. You can get the Exadata storage servers today, Exadata storage grid, the HP Oracle database machine is available today. Next slide. The delivery model is your Oracle salesman will be thrilled to take an order. And please call us if there's a problem. HP is building the systems and they will deliver them to you. And should there be the unlikely event there's a hardware problem, HP will be out there fixing it. So I'd like to now invite Mark Curry to join me. We're very excited about this partnership with HP. We're thrilled to have Ann here, and Mark is here electronically. Hi, Mark.
Hi, Larry.
So we think our joint customers are going to be buying a lot of this stuff. I hope your teams are ready to turn these things out like iPods.
Thanks for that. Listen, we're excited about it. I mean, one way or another, you and I have been working on this market for an awful long time, and the size of the data set out there is exploding. Our customers have questions, they want answers. They want to get the right information to the right place at the right time to make a difference for their customers. And I think combining the competencies of Oracle and HP to bring a product to market that's going to exponentially improve the performance of the data warehouse appliances out there is what customers want. We're excited, Larry.
And we're really proud of our relationship with HP and proud of this project, which Mark and I have been talking about for a very, very long time, is culminating here today. So I'd like to thank Mark for all of the work that HP has done, and again, we're proud to have you as a partner in delivering this system.
Well, Larry, listen, I think you and I have been talking about this for a long time, bringing the best to customers and what both our companies can do. And you know, for us, we're bringing our ProLiant server technology. And I listened to a lot of the points, Larry, that you brought up, and I'd add one, that the server and storage technology we're bringing as part of the exadata solution is completely open. It is the traditional ProLiant that you would have as an app server, a web server. It's integrating standard storage technology. We're bringing it through our standard manufacturing and supply chain. We're bringing the best of what both companies bring together in terms of our hardware support with Oracle software support. We're putting behind it Oracle's database, and I think you're getting we're bringing to the market what two great companies do best, and we're doing it together as a team. And I think, Larry, to your point, it's just exciting for me to be here with you and announce this. We got everything we got at HP behind us.
Thank you, Mark. Thank you very much. You know, Mark makes a really important point. The fact that this is open technology. The reason it's so important, I almost said when I had the slide up that we have two Intel processors, each with 4 cores. In a few months there will be 2 Intel processors, each with 6 cores. The fact that this is open technology means the technology will be constantly improving. The price will be going down, the performance will be going up. The storage capacities will be going up, the memory capacities will be going up. It's great for our customers, and we could only do it with a partner like HP. I mean, that's quite a brand to have on the machine, the Hewlett-Packard brand. And again, it makes me very, very proud.
Well, us too, Larry. And I'll tell you, I like everything about what you said except the price.
Well, it's not going to go down that much. We'll keep a little bit. We'll keep a little bit for our shareholders.
This is a great thing. I think it's a great thing for Oracle, HP, and for the market, for our customers. And as always, if there's anything we can do for any of you in terms of support, it's HP's brand behind this. It's HP's standard technology and R&D behind it. Teamed with Oracle, and again, I'd say one last time, just an exciting day for us. And we plan on continuing to innovate around the solution and bringing the best we got to it.
Again, thank you very, very much. Now,
Thanks, Larry.
Thanks, Mark. So next, I think you've listened to me for long enough, and why don't you take a moment and listen to what some of the early Oracle database, HP Oracle database machine customers are saying about their experience with the exadata storage server. Thank you.
The quicker we can get them their data, the quicker they can make informed decisions, the quicker they can collect that revenue. That's what this is all about.
Currently, our data warehouse is 15 terabytes in size, but we're growing at 200% to 300% per year. And our order volume, we needed something else to allow us to scale horizontally with a smaller footprint. The extreme performance that we get from Oracle's Exadata fits this perfectly.
Compared to our traditional designs and architectures, we've seen up to 20x increase in performance with the use of Oracle Exadata.
All our queries were faster with Exadata compared to our current systems. The fastest performance was 72 times faster than the current system.
One of our queries running on our old architecture was taking 4 minutes to complete. When we moved it to the Exadata hardware, it was completing in 10 seconds.
Oracle Exadata provides the scalability, reliability, as well as the extreme performance that the customers are demanding today.
To me, it's kind of a manifestation, you know, sell the software.